Okay, so problem 25. This is one of the harder problems in this problem set, as it's the last one. But it tells us that in an equal angular hexagon, all interior angles measure 120. An example of such a hexagon is the one shown below, with the side lengths of 2, 3, 1, 3, 2, and 2. And this is inscribed in an equilateral triangle, ABC. Consider all equal angular hexagons with positive interior sides that can be inscribed in ABC, with all 6 vertices on the side of the triangle. What is the total number of such hexagons? And they cannot only differ by rotation or reflection. Okay, so a common pattern in these types of equal angular hexagon problems is that if we zoom into the top here and we draw out this angle as 120, this means this angle will be 60, and then because they're supplementary, and then this is 120 and this is 60. So what this means is that essentially all of these little spikes you see, little triangles at each side, they're equilateral as well. So what you can do here is we write out that this equals to C, and this equals to B, this equals to A, right? Let's write it out in red. C, B, and A. That means that this equals to B, this also equals to B, and this also equals B, and so on for all the other sides. So now we can also write out this number as X, this number is X, this number as Y, this number as Z, which is like this side. So this gives us a few different equations that we can use. The first being that we can actually first find out the side length equals to 6, and this is the same for all of these different equilateral hexagons, as they all have to fit within this specific ABC triangle. So that gives us the equation of A plus X plus B equals B plus Y plus C equals A plus Z plus C. So if we write this out as having the variables X, Y, and Z as the primary variable, we get this series of equations. X equals S minus A minus B, which is larger than or equal to 1, since they all have to be positive integers. And then Y equals S minus, this equals S, equals S minus B minus C, which is larger than or equal to 1. And Z equals S minus A minus C, larger than or equal to 1. So we have these three equations, and if we convert this to A plus B, we get A plus B less than or equal to S minus 1 equals 5. And then B plus C less than or equal to S minus 1 equals 5. And then A plus C less than or equal to S minus 1 equals 5 as well. So now we can assume something here to make the solution a bit more simple. Assume that A is the smallest, B is the middle, and then C is the largest number. So because we have 5 as this, and because C is the largest number, we can start out with the number 4. So if C equals 4, and then B can only equal 1, since it has to add up to be less than or equal to 5. So we get the solution of 1, 1, 4, since A also has to be less than or equal to B. So we do the same thing for all of the C's, using C as our anchor for this problem. Because if C equals 3, if B equals 2, we get 1, 2, 3, and then 2, 2, 3. If B equals 1, we get 1, 1, 3 as our only answer. If C equals 2, if B equals 2, we get 2, 2. Oh, wait, no. We get 1, 2, 2, and then same thing here, 2, 2, 2. If B equals 1, we get 1, 1, 2. And finally, if C equals 1, then B has to equal 1, and we get 1, 1, 1. So yeah, then we get all of our solutions here, and notice that this is like a very systematic way of looking at it. So you start at the largest c, and then you go down 3, 4, 4, 3, 2, 1. And by going down through this order, it ensures that you don't miss any combinations. And same thing for the b's. You start from the largest possible, and then you move on to the smallest one. So this ensures we don't lose any number of solutions. So finally we come down to 1 plus 3 plus 3 plus 1 for each of these. It comes down to 8 total solutions. So we know that our answer should be E, which is 8. Okay, thank you guys so much for listening. And this is our final problem of this year's problem set. And if you have any problems or any questions, you can just leave a comment below, and I'll try to respond to all of you. And thank you so much for watching. Bye bye.